couple of demos, I believe. Is that correct?
Yes, we do.
Awesome. And so, Rao, you ready to give the tech update?
Yes, I am. Let me just share my update. I put the link in the chat also. I think you should be able to see the screen now. So the big news since last update has been that on last Thursday, the day after the last debrief, we have released cost accounting features after completing the tests. And it is currently running in a separate branch, the testnet 3 branch. We're in the process of merging this with the main dev branch and creating the 0917 release. And we will be releasing that soon, sometime this week. So that's kind of where we are. So we are at testnet 3, have been since Thursday, and we have done some more testing on cost accounting since Thursday, and the tests are passing. Everything is working as anticipated at this point in time. We will have a demo of cost accounting by Joe in just a little bit, and also a separate demo by Raphael on dapi.tech. I'm just trying to skip through much of this here. You can see some of the details here. Those are, they will be merged into the 0917 release. And on the long proposal times, I've been talking, I think, for a week or two about the round robin fairness constraint. And that's in place now. And then the most recent change we did was to make it on the block creator as opposed to the block sender. And that's also going to be merged and completed, merged and released in 0917. Multisig, there has not been much change. There is basically a use case or using multisig piece of work that needs to be done, which we will get to, basically to add logic to the Genesis block creation to make the co-op rev wall to be a multisig. So that's something that we will get back to. So that now basically our focus is catching any bugs, cleaning up or completing any feature work, as in little odds and ends that are left over, and a lot of focus on hardening and things that we need to do for hardening. So that's where we are. The second part of the focus is to create or simplify the tools that for dApp developers to make it easy. And hopefully we'll also get to some of the documentation as part of that. So that's to really enable dApp developers is kind of part of the focus at this point in time. Raphael's demo is in that light. One other activity we're doing in that space is we're going to restart the RCAT work. We need to rebase it to current code base. I don't think it has been touched in a while. RCAT is the digital asset management framework. So we're going to, and this will also, like getting it to work, will also help us exercise much of the code base, and in that sense also helps the hardening activity. So that's what we're doing, and then we're trying to capture performance data. It's sort of a lower priority at the moment compared to hardness and dApp developer tools. But we're trying to catch whatever performance data we can so that we have some comparative numbers for people to look at. Raphael is helping with that also, along with NutZipper and other community members. So that's kind of the tech update. Are there any questions on this before we go into the demos, or maybe Greg wants to speak and then we can do the demos?
No, let's go ahead and jump into the demos, then we'll talk about some of the issues that we uncovered while we're. I mean, I think we should be clear that we're still not merging and things like that, and just let people know exactly what's going on there.
Okay.
But yeah, let's jump into the demos first, and then we'll talk about some of the issues.
Okay, are there any questions on the tech update before I hand it over to either Joe or Raphael? Okay, so which one of you wants to go first? Joe, you want to do cost accounting, or Raphael?
Sure, I'll go first.
Okay.
Yeah. Hello.
Go ahead.
Hi all.
Share your screen. Or
right, yeah. Just one moment. Can everyone see two terminals side by side?
Yes, looks like it.
Cool. Great. So today I'll be presenting the component of the RChain platform, colloquially known as cost accounting. Some of you may know that the purpose of the cost accounting component is to limit the amount of computation that can be done in any given deploy. And this is an issue on Ethereum and RChain, similarly, because Erlang is, well, for two reasons. One, because Erlang is a Turing-complete language, which means that you can write programs that never finish running. And the second reason in relation to the first is that within the context of consensus, we have essentially, it's normal for users to deploy code that is run on other people's machines, basically. So you're running code from a Turing-complete language on a machine that's not yours. And so we have to provide some way to limit the amount of computation that can be done in a single deploy. And the way that we do that is through an economic security protocol. Basically, the idea is that upon deploying code, a user provides a certain number of units of gas, that a maximum amount that the deploy may consume. And if at any point during the execution of the program, the amount of gas has been entirely consumed, then the execution is stopped, and we proceed with the next deploy. And to guard, even against cases where users would send deploys with arbitrarily, I guess, high gas limits, we require a disincentive, I guess, for spamming the network. So there is a conversion factor that translates units of gas to units of rev. And for any deploy, the user is charged the amount of rev corresponding to the amount of gas that they give their deploy. So is everyone clear on that so far? Because it's kind of foundational.
Yes, Joe, I got a question.
Sure.
How does a person estimate how much gas they're going to have to spend before they deploy?
Good question. In the case that the deploy does not interact with any public-facing names, so those are names that are added into the registry or names that are quoted and available to everyone, such as @0, the amount of gas that a deploy consumes can be estimated by just running that code locally. And that works because in the case where you're running it locally, all of those names and the activity over those names are self-contained. So basically no data escapes because it couldn't interact with anything once it's deployed. In the case that names interact through the registry in particular, there's really the only way to estimate the amount is to run it. So I guess not so much an estimate, but yeah, I suppose that would be the simplest answer, is that if it doesn't communicate with the outside world through the registry or public names, then you can run it locally. If it does, then unfortunately you'll have to set a healthy upper bound on the contract. Does that answer your question?
Yes, thank you.
Yep, of course. So today we'll be working with the RChain testnet, which at the moment, due to the fairness constraint that we're applying, is a round-robin gossip network where 10 nodes take turns proposing deploys that are sent to them. So I guess the first thing that we're going to do is call into and listen to the logs that are generated by node 0. So the output that we're seeing right now, synchrony constraint checker, which says scene 5, means that up until this point, 5 different nodes of the network have been seen, and we require a certain minimum amount of, or a certain minimum weight of the total network weight to be seen before validators before validators are allowed to look at blocks from other nodes, just to ensure that which deploys are sent are spread out in a sensible way among the nodes themselves. The network at the moment is filled with traffic that is basically one other deploy at the moment. And I'm typing in my right console window over here. The program that's being deployed is this one, new x in nothing, which is equivalent to new x in nil. So a very simple program. So if you see log output occasionally in the left side over here that shows, refunding or deploy. Oh, actually, we have an example right here. Receive, deploy, new x in empty. So that's going to be sort of the setting in which we're going to be deploying some of these contracts. Testnet has been started with an initial amount of rev provided to a specific predetermined private key. And this private key belongs to a user that we're calling Alice. Alice has a certain number of rev that, let's just say, she was provided at Genesis. And we're going to observe how Alice's account balance is modified after she runs various snippets of code. So we're listening to node 0 right now, scene 2, which means that node 3 is about up. So we're going to, let's see, I think, yes, one dot Alice deploys node, let's just give it a healthy limit, 6. In a moment, I'll show you exactly what this is doing right now. So we have, let's just see, Alice checks Alice.row. So this is a source we're deploying. This is basically just a contract that's going to check Alice's account balance. So we're going to see in the side here, some of our logs being produced are going to indicate that there was an initial charge to Alice's account to pay for checking her balance. We're going to see some output indicating that her balance in her code has been run. And in fact, we see that here. And then finally, we're going to see, oh, sorry, no, I was thinking about something different. The only log output that we're going to see is this line here, which says cost accounting test, Alice deploys, balance of, this is her rev address, is 820,824 rev. Since we are listening on node 0, but we deployed to node 6, we are essentially witnessing here that node 0 has received the deploy for the balance check and has executed it or validated the deploy. Well, I guess I'll stop there. Does anyone have any questions so far? Cool. The next bit of code that we're going to run is actually a wallet creation source. So this bit of Erlang is going to introduce a new wallet, or a new Rev Vault with the specified, or the Rev address specified here. And this Rev address is going to basically represent the user, a second user, Bob, who is trying to become onboarded to the platform. So what we're going to see is that Bob's Rev Vault is created with an initial balance of 0, and that Alice is going to, or would ultimately be charged for creating that Rev Vault. So let's go ahead and run it. And node 6 should still do. Okay, deploy success. And so we will have to sit tight for just a little bit here, since we see that we're only on node 4 that's proposing at the moment. Okay, so here on the left, we see cost accounting test. Alice creates wallet for Bob, wallet, the vault at this Rev address, created with the balance of 0. And what we should see as a result of this is that if we checked Alice's account balance again, then it would be lower than the number, I think was, sorry, I should have, I even have a pen and paper over here so I can make note of this number, but I didn't. But
it was 820, 824 or something like that.
Very good, Ron. Thank you. Yeah, but in the, you're right, in the range of the 800 and 30,000. So let's go ahead and run this balance check again, so that we can observe this or the account deduction. So let's call. Here we see logs indicating that, you know, our baby program has been processed and is being charged for. Right. And so here we have it again, cost accounting test, Alice deploys, balance of Alice's Rev Vault has been reduced to somewhere around, or 767,684, which is sort of exactly what we've been hoping for. And this way, yeah, and I guess as I mentioned earlier, this is in the spirit of providing a disincentive for Alice to spam the network by just providing computations that do not terminate. So the final bit of the demo is going to be showing basically that if a user does not have enough Rev in their vault to cover the maximum possible Rev that would be consumed with the deploy, that deploy is rejected. And in that sense, the Rev token provides access to the decentralized compute services of the RChain platform. So in order to do this, we are going to shift think we're at 4. Yes, so let's go to 8. Okay, and node. Let's see, what did I go to? 0? Is that what I went to? And essentially what I'm trying to demonstrate here is that since Bob's vault has been created and at this point has a balance of 0, that he shouldn't be able to execute any transactions providing his rev vault as a reference. So do we have...
Joe, which validator are you running on the left side?
I thought I was running node. Well, I guess I'm running node 8. So let's see. That would mean that. Well, I don't. Let's just go back to node 0 and see.
It's not a proper demo if something doesn't go wrong live.
Yeah, it's just that our numbering is or how we index the validators is a bit confusing because so I'm not sure if this made it in because in real life there are race conditions.
You missed.
Oh, I did. Okay, so let's just go to node
Node 4.
Yeah.
While Joe is doing that, I should just remind people that so we've had wallet capabilities for quite some time. So we've had several demos where you can send rev from one wallet to another, but it hasn't been automatically wired into the gatekeeping of the code itself. So that's essentially what we've done.
Okay, so do we have center 8? Here we go. Okay, and what we see on the left on node 0's logs, once Bob's code is he attempts to run, which is I believe a balance check itself, we see in the node logs locally that when the deploy was created that Bob had insufficient funds to execute the code. This following pre-charge and refund is due to a different snippet of code. So we take that to mean that Bob's code and the effects that he desires have been successfully rejected by the network, which is, again, the first line of defense against spamming network validators. So that concludes, I believe, the functionality that we're trying to demonstrate today. So if anyone has any questions, I'd be happy to take them.
Well, I just want to thank you, Joe, for giving the demo, especially at short notice. You were not on the call when we volunteered you. So.
Yeah.
So really appreciate it. Thank you very much.
Of course.
So we have another demo. Is that right, Ralph?
Yeah, great job, Joe. Thank you.
Thanks.
We have Raphael. You ready?
Yes. Do you hear me?
Yes, we hear you.
Okay, great.
You can share your screen.
So I'll share my screen and get started. Okay. So I guess you see my screen.
Yes, we do.
So I'm going to present the DAPI project. So I've been working on it for a bit more than 1 year. So DAPI is a decentralized distribution network for files and web applications. It can also be seen as an alternative to the DNS system and the certificate authority system. So as it is written on the website, DAPI is a decentralized alternative to legacy web. So the main thing is that the system is backed by a blockchain platform. So of course it is not a blockchain platform itself, it is only backed by blockchain, and it can be seen as an intermediary between light clients and the blockchain. So the DAPI system includes a name system, just like the DNS system. So anyone can buy a name and attach information to it. But the main thing is that a name is not linked to a physical server through the IP addressing system, but a name is linked to a blockchain address, finally to a file that is that has been uploaded on the blockchain. So the main component of the DAPI system is the DAPI network, which is a set of agents who are independent one with another. So every agent that composes the DAPI network is co-responsible and co-authoritarian for the name system and the file distribution. So the main problematic DAPI tries to solve is the issue with legacy web. I'm going to zoom a bit so you see the picture. So one of the issues of legacy web is that it relies on centralized services. For example, certificate authorities, DNS servers, or final servers. So any of these components can be attacked, and it can result of it can result to you know, private information stealing or stuff like that. And the main the DAPI system relies, as I said, on a decentralized network, which is the DAPI network. So every member of the DAPI network will run a node of the blockchain. So the DAPI network is a subset of a blockchain platform. And the main idea is that the client always queries multiple nodes of the networks. And on the client side, there is a consensus layer for example, if the client receives two answers A and one answer B, he might refuse all the answers because the state is not how can I say it? Because there is some kind of fork going on. One node might be lying, or one node might be on a fork. So that's the idea, is that the client is connected to a lot of blockchain nodes, which are co-responsible for the file distribution. So it means that the web application, the assets of the web applications is stored on the blockchain, because we don't want to rely on a private server to distribute some assets or some files. And this system does not have dependency for the DNS system, so it does not use domain names or the certificate authority system. It uses certificates, but it does not use the certificate authorities. So the goal is to build some very highly censorship and attack resistant websites or web applications, or simply file distributions. Files distributed with DAPI are naturally resistant to DDoS attacks and DNS attacks, simply because there is a whole network that is responsible for file distribution and not just a single service. So I will do a quick demo of some very basic web application on DAPI. What did I miss? Okay, that's kind of all for the introduction. If you have any question, do not hesitate. So, the official GitHub account is that one. I recently wrote a first DAPI tutorial to learn to deploy web applications on DAPI. So at first, I will start my DAPI software. So in order for anyone to play with web applications on DAPI, it is required to have the software installed on the computer because it's a desktop software. It's not a web app. So I'll start it. Okay, so this is DAPI. So the first thing I want to show you is this page. This page references all the nodes that compose the DAPI network. So of course, right now it is a local network, but eventually in the future, there will be here 10, 20, or 40 nodes that can be queried to get some information from the blockchain. So what I will show you at first is this project. So this is the project I just showed you on GitHub. This is the same. And this is just to illustrate how DAPI works. So for example, this is a web application repository, very basic. There is a HTML file here. There are some JavaScript script file right here. And this CLI just compiles everything to a big base64 file and then uploads it to the RChain blockchain. So I have my RNode software right here. So we should see the information getting through. Okay, so I guess this is the deploy. So all my web application is sent to a private name, this private name. So this is the base64. It contains the CSS, JavaScript, and HTML. So this is the unforgeable name that has been outputted. And right now I am able to load it on the DAPI software, just like a regular website. So DAPI browser is a bit like a web browser. The only thing that changes is the network side, because it does not do client-server requests, but it does a client blockchain request. So we will see it in a bit. So if I passed here the unforgeable name, okay, so I got my application loaded. And so this is just like loading a file, but the idea is also to be able to play with some dynamic content. So if you take a look at the Roland file, it has a unforgeable name called light that can be on or off. And the idea is that our JavaScript will interact with this value on chain using some functions that are available in the execution context of the web application. So, for example, reading some value from the blockchain is done simply by doing a RChain.fetch. So, for example, that one. So this is the unforgeable name. And when he gets the response, he can do anything he wants with it. So we are going to test changing the value on chain. So I'm going to click. And so this is one of the main points of DAPI, is that third-party applications do not handle private keys. It is DAPI that handles private key for them. So this is a DAPI pop-up because the web application has issued a request for to send a transaction on the blockchain. So I'm going to enter my password. I can also check the code to make sure there is nothing dangerous, and I can hit send transaction. So let's see the RChain logs. So my code has been deployed here, and the application, okay, it already changed color because it pulls the value from the blockchain every 5 seconds. I can click again. Okay, let's wait a bit. Okay, so of course, this is persistent storing on the blockchain. So it is not, it is the same thing for all users that might visit the same website. So now what I want to show you is this concept. So by clicking on it, I can see that it's a decentralized application and that it has been loaded through this endpoint. And the idea of DAPI is that you can load websites if you want more security. You can and you must load them from multiple endpoints. This means that you will not trust this endpoint or this endpoint. You require both of them to send the same data. If they send something different, you just reject the answer. So right now I have changed my settings and I want two available endpoints to send me I want to query two endpoints each time I do a query to the blockchain. So I'm going to reload the website. Okay, so it does the same, but what happened is that those two endpoints have been queried and they both of them sent the same answer. So DAPI validated this multi-request and the website could be loaded. If I was doing something very, very important and sensible, I would have raised this number, for example, to 10. And if the DAPI network would have been large enough, DAPI would have asked 10 members of the network in order for us to be absolutely sure that the resource we want to load is the one that we will receive. So that's kind of the idea of DAPI. DAPI also includes a name system, as I said. So we can link this complicated string to a simple name. Okay, not found. Something going wrong. Okay, so I kind of okay, that's why it fails, that because I changed it to 10, so I must lower this number again. And then I'll try to load the light application. Okay, so it worked. So so when I talked about censorship resistant domain names here, it is basically this idea is that if the light name is available, I can book it, and of course it's recorded on the blockchain, so I own this name, and this information is always retrieved using the multi-request mechanism. It means that no single server can fool the clients by telling them that this name does not exist or maps to some other web applications. Right? So this is a file storing example. Oh, I'm sorry, this is the wrong one. You can also distribute simple files using DAPI. So this is a JPEG file that I uploaded earlier. So that's kind of everything. I had to show. Regarding the RChain community, so this release of DAPI is kind of a bit is working with my local installation. Hopefully, the next one will be backed by RChain testnet 3. So this way, we will be able to deploy web applications and test the testnet. Next week, we will show you with Sumislav a wallet application on DAPI. And the wallet application he is developing on not on DAPI. So we will do a demo of it. If you are developing some web application on RChain, do not hesitate to reach me or try to play with DAPI, because the goal is to make it very much simpler for everyone to interact with the blockchain platform. Because as a web developer, you won't have to deal with all the network and gRPC and communication stuff. It's all handled by the browser. For example, this is all the JS code of the application I show you. There is just a reading some stuff, and then sending a transaction is as simple as that, because the web application does not handle the network issues. So that's kind of everything I had to show.
Thank you very much. That was a great demo. I really appreciated that.
Yeah, thank you.
We should absolutely look at connecting DAPI to RChat. That would be a very interesting application, or a very interesting wiring up of a couple of tools. Right? So our RChat allows you to manage the assets, and DAPI would be the one that would retrieve the assets. So very nice, very nice.
Yeah, DAPI could be some sort of back office UX provider for RChat, I guess.
Yeah, exactly. That's right. That's right. Really, really lovely demo. It's obviously well thought out. So thank you, Raphael.
Thank you.
Any questions from anyone about anything we've seen so far? So we have testnet 3 is launched. Cost accounting has been demoed. Then we had the surprise win of the DAPI demo. Any other questions on that before we move on? Okay. So I want to tout the RCast for this week. Sort of talks about the big picture, sort of how RChain has been architected, and where the cost accounting and testnet 3 comes in the total set of features. And again, sort of touting this perspective that data is king, that it's much easier to build a network from the get-go that is a data management network, and then specialize it to payments, than it is to start from a payments network and expand it out the data. And that's very much been the perspective. Tomorrow I leave for China. I'll be going to Suzhou for the @ONE conference, and then going to Beijing to meet with regulators who are quite interested in blockchain, as well as developers and potential investors, and of course with the leadership of the RChain Chinese community. So looking forward to that. Busily preparing slides that will be translated into Chinese. So unless there are any burning questions, I'd like to get back to that. But so I'd be happy to yield back the 13 minutes we've got left in the hour to the community, unless there are any burning questions.
Greg, you were going to speak to the mergeability stuff that we will be doing in future.
Yeah. So just so that people are aware, once you introduce cost accounting, there are a lot more channels involved in any given row line deployment, and some of those channels lead back to, the channels that are involved are connected to the wallets that are associated with the cost accounting. So you can potentially have conflict there. So in order to just push that issue to one side, we've limited the network to a single parent. But we are going to put in the features that allow for greater merging of blocks in the next few days, and then we will then we will be able to get much better throughput. The aim is, I think it was very clear that from Patrick's demo that no user would sit there and be willing to have that kind of usability experience currently. But it's also clear from Patrick's demo, I hope, that we're within striking distance of very highly performant from a user experience that's quite acceptable. And part of that is increasing the network throughput with mergeability and other kinds of things. Let's see. I think we also found an issue with bonding. Is that correct, Rao?
No, that was resolved. That was apparently Will's misunderstanding. So it's not a bug.
Yeah.
So we're going to be able to release. We're basically merging and doing the final integration test. So we should be able to release the 0917 soon.
Okay, yeah. That's really good to hear. And then I think that we found an issue with slashing that we're tracking down right now. So just so people should be aware of these issues. Fortunately, that's why it's called testnet and not mainnet. But please start using it. It's really good to see demos like Patrick's demo. If we had 10 million of those, we'd be really happy to that would really shake out a lot of bugs. I should also mention that because I'm flying, I think I'll be just landing during the members Q&A session. No Q&A session on this Friday, so we'll push that off to the following week. And same with the RCast. There'll be no RCast next week, but there will be one the day before Thanksgiving, and that should be a really fun one. Looking forward to that. So are there any other questions, comments, things we need to touch base on?
I don't have any questions, but I would like to reach out to the community. Once again, thanks for all your support and all the work you are doing. I really want to request everyone to do more with the testnet now that it is there. We need help with hardening the network and finding bugs. So anything you can do to help either in that domain or in adding more and more dApps to it. So both of those are something that we're looking for, or tools for dApp developers. So whatever ideas you have, I'm available to work with you on to make it happen. So those three areas: the security and hardening, the dApp development itself, and tools for dApp developers. So we want to focus more and more on that to improve the usability of the network at this point in time.
Fantastic. I agree with you. Thanks for making that call. All right, gentle people, thank you so much for coming. And I think this is a major milestone we just got through. So yeah, congratulations to all. Talk to you next week, or yes, next week. Ciao.
Thank you. Ciao.
Thanks.